Using factoring to find zeros of polynomial functions. Recall that if f is a polynomial function, the values of x for which f of x equals 0 are called zeros of f. If the equation of the polynomial function can be factored, we can set each factor equal to 0 and solve for the zeros. We can use this method to find x-intercepts because at the x-intercepts, we find the input values when the output value is 0. For general polynomials, this can be a challenging prospect. While quadratics can be solved using the relatively simple quadratic formula, the corresponding formulas for cubic and fourth degree polynomials are not simple enough to remember, and formulas do not exist for general higher degree polynomials. Consequently, we will limit ourselves to 3 cases. 1. The polynomial can be factored using known methods, greatest common factor and trinomial factoring. Number 2, the polynomial is given in factored form. And number 3, technology is used to determine the intercepts, meaning graphing. Now, given a polynomial function f, find the x-intercepts by factoring. Step number 1, you're going to set the function f of x equal to 0. Step number 2, if the polynomial function is not given in factored form, then part A, you factor out any common monomial factors. Part B, factor any factorable binomials or trinomials. In step 3, you're going to set each factor equal to 0 and solve to find the x-intercepts. For example 2, finding the x-intercepts of a polynomial function by factoring. We're going to find the x-intercepts of f of x, which is equal to x to the 6th minus 3x to the 4th plus 2x to the 2nd. Now in step number 1, we can attempt to factor this polynomial to find the solutions for f of x equal to 0. So in this scenario, we're setting it up equal to 0 and trying to see if we can factor it first. So if we take a look at all 3 terms, we can factor out a common term, which is x squared. And what's left is x to the 4th minus 3x squared plus 2 equals 0. Now in the center here, we can factor this because this is a factorable trinomial. We can factor this to be x squared minus 1 times x squared minus 2 times x squared, which is equal to 0. And now that we have 3 factors that we can set equal to 0, then we can solve for x. So we have x squared, which is equal to 0, or x squared minus 1, which is equal to 0, or x squared minus 2, which is equal to 0. Now, if we take the square root of both sides, we get plus or minus the square root of 0, but 0 is neither negative or positive, so x is going to equal 0. Over here, if we add 1 to both sides and take the square root of both sides, remember this is plus or minus, the square root of 1 is 1, so x is equal to plus or minus 1. Or here, we add 2 to both sides, take the square root of both sides, or x is equal to plus or minus the square root of 2. So that means we're going to have 1, 2, 3, 4, 5 x-intercepts. So this gives us 5 x-intercepts. The first one is 0, 0. The second one is 1, 0, negative 1, 0, positive square root of 2, 0, and negative square root of 2, 0. And in figure 3, we can see that this is an even function because it is symmetric about the x-axis. So let's take a look here. Here are our x-intercepts. We can see that it's symmetric according to the x-axis. It rises on the left, rises on the right, and we know that it's an even function.